Alright, this video is going to be a quick video about the isosceles and equilateral triangles, and it's just going to talk about the properties of how the sides and the angles are actually related. So we're going to start out with the isosceles triangle. We know the definition of an isosceles triangle is that it has two equal sides. Well, what that's also going to imply is that it has two equal angles. So the angles that are located directly across from those sides, so this angle over here and this angle over here, those two are actually always congruent, so I'm going to mark those. The easiest way to find where the two angles are that are congruent is to look for the base. The base is the side that is different from the two that are marked congruent, so it's like the odd one out, and it's the angles sitting on the base. Those are referred to as the base angles. Those angles are the two that will always match. The other angle at the top is going to be the vertex angle. So if we were to just slide down where it says example 1, if you have an isosceles triangle and the base angle is 12, well, if I were to start with a picture of an isosceles triangle where two sides are the same, I know that this base angle is 12, which would then imply the other base angle is 12. So the question is to find the vertex angle. So if I wanted to find the vertex angle, I could start with 180, subtract off both 12s to find that I'm left with an angle of 156 degrees. This works if you know a base angle. The other example is if you know a vertex angle. So same thing, still an isosceles triangle. If I were to sketch it, it looks like this. If the vertex angle on the top is 4 degrees and you're trying to find one of the base angles, you could approach it the same way. I know all of the angles add up to 180. If I were to subtract, oops, let me fix that, 180. I know if I were to subtract the 4-degree angle at the top, that would bring me down to 176. So that means these two remaining angles, which have to be the same because they're sitting on the base, must total 176. So to get one of them, if I divide that 176 by 2, I find out that both angles have to be 88 degrees. So in the second part of the example, this one has to be 88 degrees. So whether I give you a base angle and ask for a vertex angle, or I give you a vertex angle and ask for a base angle, you can always find the other angles in an isosceles triangle. The other triangle that we're going to be talking about is the equilateral triangle. We've already talked about the fact that equilateral triangles have 3 equal sides. Well, when they have 3 equal sides, that's also going to make it so that they have 3 equal angles. We talked about this briefly, the fact that all of the angles would have to be the same. So if you were to take 180 divided by 3, you'd find out that each angle has to be 60 degrees. That's the only way to make it so that all angles are the same, yet add to 180. So if I were to look down here at example 2, the goal is to find x. I know to start that this is an equilateral triangle. The reason I know this is because this side, which is marked congruent to this side, is also 5. So that's going to tell me that all 3 sides are actually 5. So since it's equilateral, every angle is 60 degrees in the corner, so this angle right here has to be 60 degrees. So if I go to solve for x, I can say that 3x is equal to 60. If I divide both sides by 3, I now have that x is 20. If I look at the third example, in this example, it helps by first trying to figure out if the triangle is equilateral or isosceles. If I look at the side lengths where I have a 4, and a 7, I know 2 sides are the same, which makes it so that these right here are my equal sides of my isosceles triangle, and that 7, that remaining side, that's the one that's going to be the base. If you remember, the base is the one that's different than the other two. Using this, I now know that the base angles have to be congruent. So this one is going to be 30 degrees. So I can then keep going to find x. If I take the full 180 degrees, subtract off both 30-degree angles, I find out the remaining angle has to be 100, oops, I'm floppy, move in, has to be 120 degrees for my x. Now I have my angle. If you ask yourself, what kind of triangle do I have, that definitely makes it easier. If I look at example 4, again, what kind of triangle is it? All I know is that these two sides are both 5, which makes it isosceles. That makes this the base. What I know about these two angles is that they have to be equal, but making this thing equal this thing is not a good idea because I have a mix of x's and y's. So instead, since I know this is a 30-degree angle, and I know these two angles are supposed to be the same, I can actually just figure out how big the angles are. If I take 180, subtract off 30, which leaves me with 150. If I take that 150 and divide it by 2, it's shared equally between these two angles. I just found out that this angle over here is 75, and this angle over here is 75. So since I need to solve for x is 75. To solve for y, I can take this angle that has the y in it, that says 11y minus 18, and I can set that equal to 75 as well, and now I can solve for y. If I add 18 over to both sides, that will go away, so now I have 11y equals, we would take that to, what's 18 plus 7, 8, 9, 10, 12, 13, sorry, still slow, 93. So then last step, divide by 93 by 11, you're going to get a decimal. I think it's going to be around 8.5 when you're all said and done. There's your answer for y. Alright, last problem, not a lot of algebra to it, but a little bit of reasoning with the two triangles. First thing I notice, this triangle right here is isosceles. The reason I know it's isosceles is because these two angles are marked equal. So that's good information. This triangle right here, this one's equilateral. The reason I know that is because when three angles are marked congruent, well, then you're going to have three sides congruent. So if I start out, I'm just going to highlight blue the equal sides. I know this one is equal to this one, which is equal to this one. That's going to make x 7 for this side right here. If I continue on, I also know I have to find some angles. Since each of the angles in the equilateral triangle are 60 degrees, I can actually use this 60-degree angle to find angle z. Z over here would have to be 120 degrees because together these are going to be a linear pair. So I now have x, which is 7, put that up top, and z, which has to be 120. If I keep looking, another way to do this, I'm just going to erase a little bit of that. Since I know these two angles are the same, that makes this triangle right here isosceles. So if I were to take this triangle, it's isosceles, these two have to be the same, and this is the base. This angle z was 120 degrees, and I need to find w over here. I could actually take this triangle, if I flip it around thinking of it this way, since those two bottom angles are the same, I can actually find these angles because they're the base angles. So, that being said, to find w, I'm going to take 180, subtract off that 120 that was right here. I get an answer of 60, so that means these two base angles have to share 60, so that means I'm going to get 30 for each of them. So w has to be 30. In addition to knowing that this triangle, this red one right here, is an isosceles triangle, since this is the base, that means these two pieces have to be the same. Since this one is 7 because of this triangle, well, this one has to be 7 because this triangle is isosceles. So that means that length of y plus 4 must equal 7. The only number that would make this 7 is when y is equal to 3. So, a couple tips about this concept. When you are working with triangles, it's best to identify if your triangle is isosceles or equilateral. And then, once you know, especially if it's isosceles, make sure you're locating the base. Knowing the base is good because then you know where those base angles are sitting, and it can make it a lot easier for you to find the angles. Good luck.